In the previous lecture, we have already seen some of the population attributes. In this lecture also, we are going to see some other population attributes. Okay, so fifth population attribute is nothing but the density of population. Now, what is meaning of the density of population? The total number of population or total number of organisms per unit area. It is nothing but the density of population. That means we know the total number of population, but in how much area this population is there. So here the area is considered. That means in lower organisms we will consider the lower area, that means square feet something. But in case of human population, we would we should take the kilometers. That means the fluctuations in the area takes place. So population density is different in different organisms or in different animals. So, and this population density, it is denoted by capital N. Now, to calculate the density of population, what we need? We need to know the natality and mortality, that is birth rate and death rate. Then we should know the growth rate. If we know the natality and mortality, we can calculate the growth rate. And by knowing the natality, mortality and growth rate, we can calculate the density of population. So there are two of the conditions, or there are two of the possibilities. Either the population density is increases or decreases. So how the population density is increases and how the population density is decreases. For that, we should know that four factors which are responsible for increase and decrease of that population density. So these are, first one, it is nothing but the natality. Second is mortality. Third, it is nothing but the immigration. And fourth is nothing but the emigration. Now, natality, we know what is natality. Natality, it is nothing but the birth rate. Second, mortality. Mortality, it is nothing but the death rate. These two factors we know very well. But emigration and immigration, that are the two new concepts to us. So for that, we will take one example of people from the villages coming to the cities for the work or various purposes. This is the example to understand the immigration and emigration. Now, people eliminated from the villages, or they are going from villages to the cities. So the population of the villages is going to decrease, and when they are coming to the cities, the population of the cities are going to increase. So what is emigration? Emigration means elimination of the population takes place. That means here the emigration of the village takes place. In the village, emigration takes place means the peoples are eliminating from that population. So emigration takes place in the villages. At the same time, the peoples are added in the city population. In the city, the population is going to increase then. So here is the immigration takes place. So immigration means people adding in the initial population, and emigration means people eliminating from the initial population. Now, how these four factors are responsible for to increase or decrease the density of population. So first case, we will take how the density of population is increased. For that, density of population increases is equal to natality and immigration is more. That means the birth rate is more in that population. If in a population the birth rate is more than the death rate, and immigration is more than emigration. Means birth rate is more when there are more number of individuals are taking birth, and at the same time when there people's adding in the population is more, then there is a density of population is increased. In opposite manner, when the population density is decreasing, when there is a mortality is more and emigration is more, that means death rate is more and more people are dying, and at the same time if there is a emigration takes place, that means people eliminating from that population, in such cases the population density is decreasing. So we can conclude that in the villages population density decreases by mortality is more and the emigration is more, and at the same time in the cities the natality is more and the immigration is more because people are coming to the cities. This is nothing but the immigration, natality and mortality, and by that factors we can calculate the density of population. Okay, so there is a formula to calculate the density of population, that is nothing but the formula is there on the screen. N t plus 1 is equal to n t plus into the bracket B, capital B plus I minus capital D plus E. Okay, this is the formula to calculate the density of population. Now what these terms denotes, okay, we will see. NT, it is nothing but the density of population in initial stage, that means when initially how much population density or population is there. And t plus 1 is equal to density of population at time. Okay, means nt is nothing but the initial population and nt plus 1 is nothing but the density of population after time t. Means when we are going to calculate the population density after time, that means there is a period, that is called as nt plus 1. Now coming to the terms into the brackets, okay, b plus I, that is nothing but b is nothing but the natality and I is nothing but the immigration. Now natality and immigration will going to increase the population density. Okay, one term is there, b plus I, increase the population, minus d plus e. D is nothing but the death rate, or we can call it as mortality, and E is nothing but the emigration. Now mortality and emigration will decrease the population. Okay, so what is the meaning of that formula? The density of population at time is equal to initial density of population plus population increase rate minus population decrease rate. It is nothing but the density of population. Okay, now coming to the next population attribute, that is nothing but the growth models. There are two growth models are there. One is the exponential growth model and second one is the logistic growth model. Okay, we will see the both. First we will take in the exponential and logistic growth models, the exponential growth curve only occurred in the laboratory condition, and the logistic growth models curve are occurred in the natural conditions. We are going to see how it is possible. First we will see the example of exponential growth. So we will, you can see the exponential growth curve on your screen. This is J-shaped curve. Okay, this graph is plotted against time and population size or population growth. You can see in this graph, initially the population increases very slow, okay, and after some time it is going to exponential, okay, increasing and increasing. That means in the exponential conditions, initially population growth is slow, and after that there is an increase in the population unlimited. Okay, this is called as J-shaped curve. That means initially when organisms are going there, they are settled their life. That means they adapted there. Up to that, they are adjusting with that condition and increasing with slow rate. But when they are adapted, they are exponentially reproduced. That's why there is an exponential growth. Now in the exponential growth condition, we take the example of the laboratory. Bacteria colony is there. We are cultivating the bacteria colony. The one characteristic feature of exponential growth is nothing but there is a unlimited resources are there. In the laboratory, we are producing the bacteria. In that condition, we are providing temperature, we are providing the food, that is nutrients, we are providing the nourishment, and we are providing the space. That means everything is unlimited there. Whatever they require, we are providing them. So there is unlimited resources. That's why their reproduction rate, their growth rate is exponential, and they can have the exponential growth curve. Okay, this is one growth model. Then second opposite to that is, or different than that, it is the logistic growth model. In nature, this type of growth curve is occurred. Okay, in nature, not exponential growth model is occurred, logistic growth model. Now you can see the growth curve of the logistic growth, okay, on the screen. It is different than that of the exponential growth curve. It is somewhat S-shaped curve, you can see, okay, or it is called as sigmoid type of growth curve. Now why it is different? Because in the exponential growth, the resources are unlimited. But in case of nature or in real conditions, environment, there is a limitations of the resources after some period. Okay, that's why this type of curve is there. If you see that graph, there is a difference. Initial condition is same as the exponential growth. Okay, then the rapid reproduction is as same as the exponential growth, but after some time, in the exponential growth, the reproduction rate or the population is going to increase and increase. But in case of the logistic growth curve, at some stage the population is going to stagnant or steady. It is not actually steady, but it is somewhat steady. Okay, we will see what happens there. Initially the organisms are going to place, they are adapting. Up to that the population rate is slow. Okay, the curve is called as the lag phase. Initial phase is called as the lag phase, where population growth is very slow. After that there is a rapid increase in the population. That curve is called as the log phase, where the maximum reproduction takes place and growth is exponential. That is called as the log phase. After that, third phase is there, that is called as growth phase. Okay, or there is a curve takes place. That means there is a decrease in the population increase. Okay, there is a break to the population increase. Suddenly there is a decrease in the population increase. Okay, that is called as growth phase. And lastly, there is a steady phase, or we can call it as stationary phase, where the population is not increasing that much. Okay, it is not actually steady because the population rate is same, but when there is a limiting factor comes, okay, that means limitation of the resources, space, environment, then the organisms from that conditions are eliminating from that, they are going away from that space. That's why population rate is that, but elimination rate is also as same as the population. That means natality is equal to emigration. When people are adding and same people are eliminating, then the growth rate is stagnant. That's why in the nature there is a limiting factors comes after some time, and that affects the growth of the population. So exponential and the logistic growth are different. In the laboratory condition, no limiting factors, so the growth curve is going on and on. But in the logistic growth curve, there are in the nature, there are some limiting factors which will stop or which will reduce the reproduction rate. These are the two conditions, growth models. These are some of the attributes we have seen.